Okay, I just started the recording again and unmuted myself. Thank you. So welcome everybody. This is our second to last all team meeting. Tonight we're going to be talking about altimeters, but we have a small problem, and that is the altimeters that I would have preferred to use are not available right now. There have been supply issues with lots of things, as you know. And the altimeters that I have ordered, which are promised to me, are coming from South Africa. And they haven't arrived yet, but I've been promised that they will be here this week. And if that's true, we'll have them in your hands next week, if not later this week. And you can use information based on tonight and perhaps some extra stuff that we'll provide you with to make use of them and get them wired up. So we will talk about altimeters tonight, what they do, how some of them work, the ones that we happen to have around. But I'm not going to try and instruct you on the ones that we're actually using this fall, in part because I'm not that familiar with them and I don't have them in hand. So we'll get back to that. Next week will be the final all-team meeting where we will try to polish off a bunch of different things, including some small calculations of ejection charges, how big they should be, and how to calculate grinding down delay grains and a variety of things like that. Before we jump into altimeters though, I'm going to turn it over to Sophia to tell you a little bit about how her build is going. Although I think before she does that, she might even ask you how your build is going. So here she is.
Okay, hello everybody. I've gotten a few emails when it comes to general build progress, but how have things been going? Kind of want to go through the room. Maybe we can start with Augsburg, just because it's alphabetical. Can you maybe say a little bit about how your build has been going so far and if you've ran into any sort of troubles?
Yeah, so our build has been going pretty well. We have, so the stuff relating to the fins and like the motor mount done and the avionics bake it. And then we did the nose cone, with that type of stuff. And then we have like 4 more meetings scheduled, so we'll definitely get it all done. But it's going pretty well.
Good. All right, and then we'll go to Bethel. Are there any representatives for Bethel?
We're still pretty far behind on it, just trying to get materials and stuff put together since it's our first build as a team. So
yeah, for sure. All right, and then are there representatives from Century?
Yes, hi, I forgot to put the thing in the title. The build's going pretty good. Got the motor mount assembly all finished, the nose cone modification. Only problems that we ran into was one of the fins, when we were gluing them onto the motor mount assembly, didn't seat properly. So we had to sand it back down and then re-glue it. But aside from that, it's gone pretty good.
Good. All right, and then let's go to Duluth. Representatives from Duluth.
It's going pretty good. We've had some troubles with the epoxy, but we're starting to get it.
Okay, good. And then Fond du Lac.
Go, Lena.
I just epoxied on the eye bolt stuff and that ring. We've got the fins tacked on. That's about how far we are.
Nice.
But we didn't do the nose cone yet. I've actually forgotten where you taught us how to do that.
Oh yeah, cutting the slot in the shoulder.
Is that in your slides?
That is in my slides, yes. It's a little towards the end, so maybe you didn't see it, but it is in my slides now, if you check back there. So you can refer to that to see exactly how to do it. And I did it as well, so I can show you. All right. What is next in the alphabet? Hamlin?
We have most of like the motor mount stuff done. Trying to get the knot tied, but I can't seem to get it correct quite yet. And then once that's done, we'll glue everything else in.
Perfect. And then Inver Hills.
Right now we're doing pretty well, I think. We've done the motor mount assembly. We've started on the avionics bay, and we're currently working on the nose cone.
Good. All right, and then Normandale.
Hey, we have our fin can mostly assembled now, and our we just epoxied together our AV bay, so everything is going pretty well.
Good. All right, did I forget anybody? I don't think so. Perfect. All right, well, it's good to hear everyone's build is going relatively smoothly. But I'm updating the slides as I go. I think maybe one of you are kind of getting on my tail, so I'll try to make some progress tomorrow. But if you've been keeping up with that, you can see I finished the fillets on the fin can. So I have all the external stuff done. One thing I did make a mistake though, and you should have seen my email, was regarding the lower rail button. So the instructions are a little unclear in that they don't mention anything about the rail buttons until after the external fillet step. So I had sealed this up, and then I read the rail button step, and then I realized I could no longer get into this section. So in order to properly install the rail buttons that are included in this kit, you do still need access to this inner part of the body tube. Thankfully, we have a spare kit that I'll be using just to demonstrate how you would install this bottom rail button. Has anyone sealed this fin can up without putting the rail button on? Good. So my rocket will be a little bit different in that I'll have to have some sort of just external launch guide or launch lug, which is fine, but it just means it'll look a little bit different from yours.
It turns out there are actually two options. One is to use a rail button that screws into wood, in which case you could screw it into the very bottom where you have your wood centering ring and your thrust ring, or else we might have you just mount something completely externally, but that will have to be done with epoxy. The downside of the epoxy part is you can't do that on site at the last moment. You have to do that in advance. On the other hand, you could potentially add a rail button that screws into a centering ring, even on the launch site. You don't really want to, but it could be done. So we'll have to give Sophia some additional pieces. It's not that she doesn't have the pieces. She has the pieces. She just can't reach where the pieces need to go.
Yes.
The upper rail button, on the other hand, we'll talk later about where to place that. And since that will be in a part of the rocket that you can access even later, this should not occur, as in we won't lock ourselves out for the upper rail button. It's the bottom, it's the lower rail button that's giving us trouble.
Yes. So in addition to that lower half there, I've also started working through the avionics bay. So I think last week I had the 2 coupler tubes installed, but now I have, hold on. I attempted to sand down the bulkheads a little bit more, but I think I still need to do more sanding. But I did, okay, yeah. I did install the hardware on this end, so you can see I have these, I epoxied these nuts and washers on. So it's this is a permanent installation, which is a little bit different than I've done in the past. Usually I will, yes. So back to the lower rail button. I would suggest, so if you look into the instructions, you'll see you put the rail guide or the rail button on here, and there will be some sort of weld nut on the inside. And if you read through the instructions when it comes to epoxying in the fin can, you need to slide that top centering ring past the weld nut that is in place for the rail guide. So that means you will have to cut some sort of notch into the upper centering ring to allow for you to actually slide everything through. preferably don't want to have that notch in the same side as where that eye bolt is epoxied in, just because that might make life a little more difficult when it comes to making that notch. So I would suggest having it on the opposite side. If that means you need to redraw, that might mean you need to redraw a new launch lug line, just so you're avoiding that, but that's not the end of the world. Yes, but for avionics bay, usually in the past, I've had both end caps able to unscrew them and pull stuff out. These instructions, they had you permanently install the nuts and washers on one side, which does kind of help you out a little bit so you're not constantly trying to push these threaded rods back and forth. Kind of makes it a little more stable in my opinion.
But is that the top side or the bottom side, or it doesn't matter? I think it actually should matter. So
it does matter, yes. So this, I believe, should be the top.
Good.
Yeah, and then the bottom is where I can slide in my avionics bay when I'm all done. So I'll take off these wing nuts when that time comes, and then I'll screw them back on to secure the bottom cap in place.
And have you made a sled or not yet?
Not yet, but that will be most probably just something like this. So in this case, I think they just laser cut a slot of wood. They also had these pieces here to help it guide itself onto the actual threaded rods. Yeah, there's another example. I don't know if
we'll talk through what sleds could look like and encourage you to build a sled even if you don't have all the things in hand to put on the sled just yet.
Yeah, and then I did start on the nose cone. So as you can see, I cut a slot in the bottom shoulder here. You want to make sure you cut something that's big enough for you to fit a pliers in, because my first time I didn't, and then I realized I couldn't actually get anything in there. So definitely do that. But then I haven't screwed it down completely, but there should be a lock nut on the bottom here, and then your forged eye bolt. And this will be, instead of using this thinner plastic joint as the recovery attachment point, we'll be using the forged eye bolt as the recovery attachment point.
It looks like you didn't get the memo that you shouldn't dress the same color as your nose cone.
Yes, yes, it's really hard. But I think that's mostly where I'm at. Yes.
Okay. Questions right now for Sophia about what she's done or about what you need to do or do next? In particular, if you're not following what she has on the slides or could use some more advice, anybody?
I had a question about the recovery harness. There is two different ones that I noticed in the kit that look very similar, but I think one's a little bit wider on the rope. Does it matter which one I use? Because it was saying to attach it at the top of the rear centering ring eye bolt.
Right. I attached the longer one, I believe, to the bottom section here.
Okay. I suspect one of those came with the AV bay and one of them came with the kit. Now it might be a little hard to tell which is which because our kits kind of came apart, right?
Yeah.
It probably doesn't matter too much, but I think I would have done what Sophia did, use the longer one with the bottom section of the rocket, in part because that's the longer section of the rocket.
Yeah. Okay. I also did read through the instructions to make sure it didn't, like, you know, use slightly different vocabulary in places to indicate which one they wanted where, and there was really no indication. So I just did the longer one attached to the bottom section.
Yeah, I know. So it was kind of unclear as well. Okay, thank you.
Mm-hmm.
Okay, so to reiterate, although this is not in the slides, you want to place your bottom rail button inside of the airframe sort of as low as is practical. But since it has that flange on the inside, it can't be right at the very bottom because the very bottom is occupied by your centering ring, and then below that is your thrust ring. So maybe an inch up or so. Make sure you modify your upper centering ring as necessary so you can get past that. And you need to glue that in place. And the reason is if you don't glue that in place, when you try to screw something into it, it will just spin on the inside. And you can't hold it with your fingers or tools because, well, I suppose you could add your rail button before you close it up. I don't think that's necessarily a good idea. Glue those flanges on the inside of the rocket. Make sure you don't get any glue inside of the threads. And then we can add the outside parts of the rail button itself later. Okay, so what you'll do is you'll make a hole that's the size of the barrel, and then you'll have only the barrel sticking out, and the flange will be glued on the inside. Let's talk about payload bays, avionics bays. So essentially, the portion of the rocket where you could put something to carry, which could be a payload, it doesn't have to be necessarily avionics associated with making the rocket perform, is just referred to as a bay or a payload bay. And typically a payload bay or an avionics bay is separated from the remainder of the rocket, especially the parts where there are explosive charges, by a bulkhead that goes completely across the entire diameter of the rocket. On the other hand, you almost always have to make holes in the bulkheads because you're going to be putting on eye bolts and other things like that, so that you will puncture your bulkheads. But the trick is to puncture them and then to fill up the holes with metal and other things so that you don't actually get gases, explosive gases and corrosive gases going into, in this case, an electronics area. So we saw that Meteor rocket, for instance, before, that had the lower section, the upper section, and then the avionics bay is built into a coupler tube. Now, if you were not flying this as dual deploy, but only having the lower section of the rocket do anything, you could use the entire upper section, coupler tube, and all of everything above it as a payload area, I suppose, in which case you might not bother even putting a bulk plate across the top of the coupler tube, but you would still want a bulk plate across the bottom of the coupler tube to minimize the amount of volume that you have to pressurize for getting your drogue parachute out. So this rocket is very unusual in that it uses two, I think they're probably 6-inch long sections of coupler tube to make an avionics bay. I've never seen such a big one. Usually you only have one 6-inch long coupler tube. And so you won't be tight compared to what it could be. If you build several rockets, and those of you thinking about being in the Midwest competition, for instance, will build several rockets, I would suggest you don't duplicate the length of this avionics bay, but rather make one that's more appropriately long. In other words, significantly more concise than this one. One thing about it, why don't you hand me that? Or actually hand me this one. Hand me this one. This is from the Meteor rocket. If I, maybe that's not great. Give me that one. It doesn't have things tied to it.
Okay.
Okay, so a couple things about this. One thing is that it has a section in the middle. We're going to call that the collar. The collar is made of airframe tubing. And so when the airframe comes on this side and the airframe comes on this side, you'll still be able to see the collar. It will match the rest of the rocket. But the nice thing about being able to see the collar is that's a part of the avionics bay that never disappears when you assemble the rocket. So if you have a screw switch, for instance, you want to put it there because then you'll be able to see it at all times. Or if you have a hole for venting your avionics bay, we'll talk about that more next week, but perhaps put holes in the collar so that you don't inadvertently cover them or have to worry so much about lining things up. On the other hand, we'll also talk about this next week, there will be holes in other parts of the avionics bay, which will need to get lined up when you assemble it. So that won't be completely willy-nilly. And then here is one of the bulk plates, one of the eye bolts, and then the threaded rods, which are here, okay, around the entire length of the avionics bay. And the idea is, when I take the external part off, this is the structure on which you can build things. And the reason it's fully threaded is so that you can screw things on this end, screw things on this end, and tighten them down, and then have a good solid connection between this eye bolt and then the eye bolt that's going to go down here on the other end. In other words, it's essentially recovery harness to eye bolt to wood to metal to wood to eye bolt, and it's really strong in tension, which is necessary because you're going to really yank on this thing when you pull your parachutes. So what you need to do is you need to build a sled. A sled is something that just sits literally on top of these threaded rods. And typically with the sled, you do one of two things. The classic way to attach the sled to the threaded rods is like this. In other words, to have metal tubes glued to the underside, for instance, of the sled, and the threaded rods literally go through those metal tubes. You'll notice that this particular sled actually has notches on the end. And the reason for those notches is that in the middle of your bulk plate on the inside, there's likely to be a nut right in the middle. And so your sled actually can't go up against the end, and you might want to use notches to allow you to get close to that. What you don't want is your sled to be too short and to be wandering back and forth. You want the sled to literally be tight against one end, both ends, frankly. And one possible way to do that is to make the sled so it's not flat on the end, but rather is notched to accommodate things like those nuts. Here's another possibility. So this particular sled looks similar, except it doesn't have any metal on the bottom. Instead, what it has on the bottom are pieces of wood, MDF, with holes in them. So there's pieces of wood on this end, there's pieces of wood on this end with holes in both. And as you can imagine, the threaded rods will go right through those. And so that would also serve to keep your sled where it needs to be as far as rattling around. It's also a good idea to keep this, to make the sled approximately as wide as you can. And that's maybe not so necessary for this particular kit, but let me show you these two sleds that I have. They both have something in common, which will be different from your kit. And that is on the surface, here we go, on the surface of the sled, right against the edge, is a screw switch. So this particular screw switch, I'm going to actually reach it by poking a screwdriver through a hole in the airframe. Now, your kit actually came with a screw switch, which was handy, and that screw switch is designed to be mounted directly in the airframe, so you don't have to put your screw switch on your sled. You just have to have long enough wires on the screw switch so that you can take the sled out and the screw switch stays with the rocket. But the key is to have your sled kind of as wide as is practical so that the screw switch is right next to the wall, so you don't have to reach too far when you go looking for it. And then, of course, the hole in the airframe needs to line up with the screw switch. And this screw switch is pretty liberally glued in place. And this screw switch is not liberally glued in place, but it's actually put in place with a zip tie. That's probably not as good of a solution. But it turns out that the switches in general are usually quite stiff. So you not only have to turn them, but you have to push on them and turn them. So that's called applying a wrench. And you need to make sure they're held in place solidly enough that when you wrench on them, they don't come loose. Because guess what? If they come loose, pretty much you're not flying that day, especially if the way you were trying to hold them in place was with epoxy, which is now going to take another day to dry before you can try it again. So make sure your screw switch, this again might not be a problem with yours if it's mounted in the airframe. I haven't actually taken a look at this one, and I don't think you've mounted your screw switch into your collar yet. But if the screw switch that came with this kit is in some sense better, as in it mounts in the airframe, then you can easily push hard on the airframe and it's not going to come loose. You just have to make sure that you have long enough wires. My recommendation is have long enough wires so that you can take your sled, which goes inside, all the way out and work on it and then put it all the way back in without breaking any wires. In other words, have the wires essentially a foot long, maybe even more in some cases, so that the sled can slide out, be fully exposed, be worked on, and then slide all the way back in without having to adjust any of the wiring. Okay, so that's something that you could do. You could not only assemble your threaded rods, your bulk plates, do the epoxying of this, but you can start to work on your sled. And then we will eventually mount things onto the surface of the sled and run wires around. And even if it's not quite clear where they will go or how big they will be, you will be ready for them as soon as they arrive in the mail, which hopefully will be soon. Okay. Also, I would suggest they propose that you make the one end of your avionics bay permanent, as in this has been glued on, and these threaded rods now stay with the top. So the idea is the tubing comes up from the bottom, the sled comes up from the bottom, the final cover comes up from the bottom. And so there's sort of an order of operations when you're assembling this thing, basically. And if you are ever going to get confused, you could even write top on one and bottom on the other, just to make sure that you put the thing in the right way around. This is called a fully removable avionics bay or AV bay. This is a good idea, fully removable. What that means Well, it means that you can take this ab bay and put it in another rocket if it has the same diameter, for instance. We're only building one rocket for this particular project, but that's useful. And also a fully removable, fully disassemblable ab bay is much easier to fix or to replace parts if anything ever breaks or goes wrong. So although it's sometimes tempting to glue it all together, we do recommend that you try to make this as serviceable as possible. And then again, the collar part is the place that you can always see, you can always touch. And so it's possible to have an ab bay that doesn't have a collar, but in that case, it literally can fall into the rocket while you're assembling it. That's generally not a good idea. So I like a collar, although I wouldn't have made my collar. Usually a collar is more like, you know, one centimeter high or maybe 1 inch high. If you think about it, the pieces of airframe form a certain length of the rocket. And if you add a collar, that's more airframe. So that just makes the rocket longer and longer. You also have to make sure that whenever you're using a coupler tube, you at least have as much depth as you have diameter. If you only have, you know, 1 inch worth of depth here, it won't actually manage to keep the thing well enough lined up. You need to make sure this goes well into the rocket airframe so as to keep it lined up. So herein is a problem if you have a 3-inch diameter rocket and a 6-inch piece of coupler tubing, and then you want to use 1 or 2 inches of that 6 inches worth for collar. Now it's not sticking out enough on either end to actually keep the thing well lined up. So you might need an 8-inch long coupler tubing if you want to have 1 or 2 inches of collar. In this case, they have 2 6-inch, so you have 12 inches long, and then of that, about 4 inches or something like that is set aside for coupler length. Okay, one moment. I see one person waiting to jump on. Here we go. So since this is fully removable, you have to be sure that you add your recovery strap and tie it properly to your fin can before inserting that, because that's glued and you won't be able to reach that. On the other hand, you can tie onto here and untie later on. And so my recommendation is that you be serious about your nuts, but don't necessarily glue the nuts shut, because as soon as you glued a nut shut, then you really can't service it anymore. So just make a good nut and don't glue it shut at these points. That allows you to take off the avionics bay altogether, take off the nose cone altogether if necessary. But the one that's deep in the rocket by the fin can, you can't ever reach it. So you might as well, as Sophia suggested in her slides, you might as well at least put a little bit of epoxy on that one just to be really sure it never comes loose, because you can't fix it if it were to come loose. Okay, so let's talk about av bays and altimeters. So in this case, an altimeter is a device which can sense what you're doing. So it has sensors. And then it also can fire ejection charges. So in other words, it can apply a voltage. So it has to have a battery to power it. And then it can apply a voltage to 2 lines, which would be attached to an E-match, an electronic match. And the E-match itself would be typically encased in gunpowder or some gunpowder substitute to cause an explosion. That's called an ejection charge, and to pressurize a certain part of the rocket and force it apart. Okay. So an E-match, like a resistor, is not a polarized item. So you can, it'll have 2 wires on it, but you can apply them either way. On the other hand, there definitely are going to be things, including the altimeter itself, that have to be wired exactly right. So, and then we also will use batteries. Our recommendation, I'm looking at my notes and trying not to forget things. Our recommendation is that you use Duracell batteries. So those are the copper top batteries. Those are not my favorite batteries for certain projects, especially ballooning projects. But it turns out that 9-volt batteries are multiple cells. And on some manufacturers, they're literally press fitted together on the inside. And on other manufacturers, they're actually welded together on the inside. And it's possible, under the rigors of a rocket flight, that your battery can fail inside. Literally, it can break on the inside. And if your battery breaks on the inside, you won't even be able to tell, other than the fact that it's not working. So Duracell are the most rugged batteries on the inside. And so that's why we recommend that you use them. Let's, here's what I think I want to do. I think I want to step over to the whiteboard over there. just show the whiteboard on this camera and essentially draw a generic altimeter and how it needs to be wired. And then we'll actually show you two altimeters. One is a stratologger. Sophia will show you that. One is a Raven. I will show you that. And it turns out neither of these are the type we're actually using this fall. We're going to use what's called an AIM USB altimeter. These are all relatively low-cost altimeters. The stratologger is the least costly. The Raven is the most costly of these three. But the AIM USB was chosen because it was the only one available at the time I needed to place the order. And I still don't have that. Okay, so what we'll do is we'll look at the wiring. And the wiring will be for a generic altimeter. The wiring has to accomplish the following things. And then if it's a Raven, you need to make these things work exactly this way. And if it's a stratologger, they have to be slightly different. So pay attention to the wiring that goes with your altimeter. But some of the teams around here, for instance, already have probably Ravens. If you took these lessons or if your institution took these lessons some years ago, that's what I handed out at one point. You might have stratologgers around. So this may be valuable. So here's what I want to do now. First of all, Sophia, I want you to sit here and watch my computer and make sure that if anybody shows up, you let them in.
Yeah.
And I'm going to stand over here. Okay, and I could actually benefit from, this is fine. I'll just move your computer. I just want to be able to make sure that one.
Yeah.
That where I'm drawing on the board is actually visible on the screen. Okay, here we go. Okay. So first of all, just a little bit about how the wiring essentially has to go. So if this is your altimeter, is that too tall? No, that's good. So this is my altimeter. And notice the thing that you have on hand, which is called an altimeter 2, is not an altimeter, as in it's not something which can fire ejection charges. It's literally a data logger, and I wish they did name it altimeter 2. I don't like the fact that they stole that word. There's also an altimeter 3. We need a genuine altimeter which can actually do something, as in sense what's going on. That's what they can do, and then do something about it. That's what they can't do. Okay, so Raven, stratologger, AIM USB. These are the three types of altimeters that we'll talk about at least a little bit, especially the first two. Okay, so your altimeter needs a battery. This is typically going to be a 9-volt battery, although it's possible to power these things with other voltages. You'll have to look at the specs. And so there will be some place on the altimeter that will be the battery connection. On the other hand, you also need a switch. So let me just draw the switch over here as if it's a disconnected wire. So there's a switch that's open. And so typically, if you have plus minus, typically you would perhaps put the switch in the positive line, in the power line, okay? And so the altimeter will have a place for power, and the altimeter will have a place for ground. Ground in this context just means low voltage or lower voltage. And so there it is, now the altimeter is powered. And now what the altimeter needs to do is it needs to apply voltages to the ejection charges. So let's assume that there is one ejection charge. I'm going to draw it here. Injection number 1. There it is. And that's going to have 2 wires coming out. And so presumably there will be a place on the altimeter to attach the ejection charge. That might be for the drogue, for instance. We'll write APO. APO just means apo, something that I want to fire at apogee. Okay. And then let me just say that there's another one somewhere else. I'm just going to draw it on this side. Ejection number 2. And I'm going to call that main. And the reason is that's the charge I want to explode when I'm going to get my main parachute out. And if you think about it, vertically speaking, the drogue will be underneath, physically underneath on most rockets, the location of the avionics, and the main will be above. And the reason the drogue has to be underneath is because it's also tied in with the motor eject. The automatic explosive charges built into the motor. So probably I shouldn't have drawn that up there. I probably should have drawn it down here. So let me just draw it down here. Ejection number 1. That's going to go off at apogee. Erase this. The reason I want to point this out is that ultimately you'll have an altimeter with 2 wires that go up and 2 wires that go down. The 2 wires that go up will go to the main ejection charge. The 2 wires that go down will go to the apogee, the drogue ejection charge. And then when you program the altimeter, you have to be really careful that you know which channel. And some altimeters have 2 channels, and some altimeters have more than 2 channels, allowing them to fire more than 2 charges, or redundant charges or something like that. Okay, so that's sort of the generic wiring, and then the wiring will be sort of specific for Raven, specific for stratologgers, etc. Let me do one more thing. Let me draw something that looks a little bit more physical. So if here is the top plate and the bottom plate of an avionics bay, our proposal is that on the top plate, you put a 4, this is a little hard to see with my lights. That's a little bit better. Okay, put a terminal block up here. And on the terminal block, you can have 2 wires that go inside. And then here is the charge, ejection number 2. And the reason it's handy to wire it this way is if these wires here that go inside are sort of permanent in some sense, they have to penetrate the plate. But then all you have to do is disconnect the ejection charge and put on a new ejection charge. So when we do our flight, we will actually explode your charge number 2 in advance of flying on the ground. We'll do an ejection charge test on the ground. And when we're finished with that, you'll definitely need to replace that before you fly. And being able to just disconnect it without soldering and stuff like that would be useful, okay? So these 2 wires will come in to your sled. And on your sled, you'll have your battery mounted, and also you'll have your altimeter mounted. And then also from the sled, you'll have, from the electronics, you'll have 2 more wires, and those wires will go out to a second terminal block. And then here is where you would wire ejection charge number 1. So in the case of the stratologger, do they have names for the channels? There are 2 channels in a stratologger.
There's drogue and main.
So drogue and main. So on the stratologger, you need to wire the bottom plate to drogue and the top plate to main. On the case of a Raven, there are 4 channels, and they're named apo, that's apogee, drogue, main, and then number 3 and number 4. So we will actually not even use number 3 and number 4, but we're going to wire apo to the ejection charge number 1, and we're going to wire main to ejection charge number 2. Now, my proposal is, and then of course, also coming out of the avionics will be the wires that go to the switch. And the switch will be mounted on the outside of the airframe. Actually, the switches are not mounted on the outside of the airframe. The switches are mounted on the collar of the avionics bay. But my proposal is that you have long enough wires that go from this terminal block to the electronics, from the switch to the electronics, and from the bottom plate to the electronics, that you can physically take the sled all the way outside of the tube, completely outside of the tube, and still work on it without breaking anything. In other words, the wires on the top in particular have to be the full length of the tube and then some. The wires on the bottom, those could be somewhat shorter. And then the wires from the switch have to be at least half the length of the tube, plus maybe half the length of the sled. That's minimum, so that you can get the sled out of the avionics bay without breaking any wires. So there will be kind of longer wires than you might expect inside. Okay, fine. That's generically how it's going to work. Now let's do the following. Let's talk some specifics. I don't know if you want to draw on the board or not, or show the stratologger on the camera, but let's talk approximately about how to wire a stratologger and what to expect in beeping patterns. So here's the deal. When you turn these things on, they will beep, and that's how you know what they're doing. So the Raven will have some beeping patterns, Stratologger will have some beeping patterns. They might even have flashing lights, but if they're inside of a rocket, you won't be able to see the flashing lights probably. So you have to listen for the beeping patterns and know what to expect. Okay, so I'm gonna let Sophia talk about Stratologgers first, and then I'm gonna talk about Ravens for a moment, neither of which are the actual altimeters we're using this time around, but this will give you some information about the variety of things out there. What would you like to do? You want to use the camera? Or is there anything on your screen? I don't think there's probably anything on your screen.
No.
I want to share my screen and show the program for the Raven.
Okay. Hello. So here, maybe you can see it. I'm really hoping it goes into focus. Okay, maybe not. But here is a Stratologger altimeter. So pretty small. But as you can see, there's a lot of these blue blocks over here. And all of them have labels. You can't see them, but believe me. So you see this one on the side here, and that is for the battery. So there's a plus and a minus. And then on the top here, we have the switch. So that is if you use an external screw switch or something.
Which you will.
Which we will.
If.
Yeah.
That's where you put your switch.
Yes. So in this case, we do have one. And then there's the main and drogue. And then there's also capabilities to pull the full data profile that is collected off of it. It comes with like a cable that you can plug into your computer. There is also an interface you can use to program certain features on the altimeter, but there's also a button here that allows you to customize certain features. So these certain features include if you want to delay when to do your ejection charge at apogee, so at drogue. So in some cases, what we have are redundant altimeter systems. If we really want to make sure our electronics function and our charges go off. So say at apogee, you know, I have two of these. At apogee, I have one of my drogue charges set to fire right then. Then I might have a redundant system with my drogue charge set to deploy 3 seconds after apogee. So that's a way to make extra sure that at some point something is blowing off that half of the rocket so my drogue can deploy. And then when it comes to main, so you know, we don't always want to deploy our main chute at apogee because that can make it go really far away if it's a windy day. So the features that come with this main terminal block here is that you get to choose at which altitude it is deployed. So I think default is it is at 700, but you can either use the button here or the online program to change whatever altitude it deploys at. And then, so like Dr. Flaten mentioned, there is a beep pattern for this altimeter. So when it is plugged in and you turn the screw switch on, it'll start just with some initial beeps. I think I have the whole sequence pulled up just so I could tell you for sure. But it'll start with, I believe, battery voltage. Double check here. But then it will also tell you the previous altitude of the last flight, as well as indicate continuity. And that basically tells you if there is a continuity between the ejection charges that you have wired up here. So if you just have something connected to drogue, you'll hear 1 beep. If you have something connected to main, you'll hear 2 beeps. And if you have things connected to both main and drogue, you will hear 3 beeps. So that's part of the reason why at rocket launches, you'll see people standing around in a circle by their rocket while it's on the launch pad, listening really hard because they're listening for these beeps to make sure they have continuity, that their battery is charged, and just making sure the electronics are functioning properly. I think that's all I had to say.
Okay, that's fine. The Stratologger is a low-cost device. It works fine, but it turns out the Raven has more features and is wired slightly differently. I'm going to actually show you how it's wired, and then I'm going to show you one. Oh, man. Is it here? Is that able to see my board?
Yes.
So here's actually an important point. When you put your battery on your sled, make sure that the battery is mounted with its terminals down, okay? That means that while you're accelerating, the terminals are ground into their contacts even more firmly, as opposed to if the battery was right side up in some sense. It's possible that the rocket could get away from the battery and you would lose continuity and lose your connection. So here's how the Raven actually gets wired. It's a little bit different. The battery has plus and minus, and then the Raven across the bottom has a place that's called plus in. So as you might imagine, that's going to be wired to plus. A place that's called GND, ground. So that would be wired to minus. And then here's where it gets a little bit different. The next one is APO, and the next one is main. And so, but there's not two terminals. There's only one terminal for each. So the expectation is that your ejection charge number one is wired to APO. And this is what I can find a little bit odd. It's wired to high power. And then ejection charge number two is wired to main, and it's wired to power. So in other words, these things are held high, and the way to make them fire is to ground APO or to ground main. That's not how I would have designed it, but they probably had good reasons for it. Okay, so instead of applying power, you actually leave it at high the whole time and you apply ground so as to fire these things. And then number 3 and number 4 can be used for additional ejection charges if you want to. We weren't planning to do that. So that's the wiring for a Raven. We'll get to the wiring for a AIM USB once we have them in hand. You can look it up if you want to. But let me just show you what one of these things looks like. And the beeping patterns. So here is a Raven. And here's the battery. And the battery terminals are on the bottom. And then the plus for the battery. Aha, I forgot to put between the battery and any connections to it. Why don't you just go ahead for the record. Add a switch, please. Okay. So basically right next to, between the battery and the plus terminal, he's going to erase the line right there. Just erase the line right there. Yep. And just put a switch in right there. Thank you. So, okay. So basically this allows us to completely turn off the power to everything. That's great. Thank you. Perfect. Thank you. So in this case, I have a switch on the side. It's attached to the red line. And so it's attached to the positive. And then the ground goes straight to the terminal block on the Raven, and the red goes to the switch, and then the switch goes to all of the wires, which are going to head off in different directions, and also to the powering. And so the way this actually works is when I turn it on, I just have to screw in the switch. Let me grab a screwdriver. And let's see if you can even hear this. If I bring it close enough, you might be able to hear it. So when I turn this on, the first thing it'll do is it'll beep out. The number of beeps is the voltage of the battery. There should be 8 beeps, maybe 9 beeps if it's a fresh battery. Let's listen. So I heard 8 beeps. Okay. And now it goes into its what's happening mode. And so it will give you high beeps for something that's attached and low beeps for something that's not attached. So right now it's high, high, low, low. So that means APO is attached, main is attached, 3 is not attached, 4 is not attached. And attached to what? Do I have explosive charges? No, I don't. What I've done is I've actually put LEDs on this. And so this is actually a nice feature about Ravens, which won't be the case with any of these other devices, is you can use some software that allows you to pretend that it's flying and make sure, in this case, the lights go off at the appropriate time. So I'll show you what that looks like. One moment. I will try to show you what that looks like. Ah, the beeping pattern just changed. I laid it down flat and it said, you're not ready to fly. You should be vertical. So in other words, it knows that you're supposed to be vertical and it's not willing to tell me that I'm flight ready when I'm horizontal. Okay, so let me just share my screen here. One moment. So what I'm doing is I'm running the Featherweight interface software. This is the software that comes with, or that you can download for free. And I need to tell it that I have here a Raven. Oh, sorry. You are running. Ah, never mind. Okay, so here's a nice thing, and that is the Raven and the other devices will have something similar for the most part. They have, how is it that Apogee and how is it that Main and how is it that 3 and 4 are programmed? So in this case, Apogee, I want to program, so I want the pressure to be increasing. Okay, in other words, you've gone over the top and you're on your way down. I want to make sure that it isn't, for instance, has the velocity too low. And then for Main, I want not only the pressure to be increasing, but I want it to be definitely off the ground. And the velocity is not too high in this particular case. So since this isn't the altimeter we're using, I think I'm not going to bother getting into all the details of what could be done here, other than to say it's possible to customize each of these devices, including the Stratologger. And usually they will come with sort of a reasonably appropriate set of parameters. Here's what I want to try though. I want to try to go to CalTest, and then I want to see, oh, you know, this isn't going to work. Basically, I just downloaded this onto a fresh computer today, and I don't have all the drivers. Sorry, my apologies, but it turns out that with a Raven, you can actually pretend to fly by clicking here, and then you can click again, and it will stop burning, and you will notice that the altitude goes up and up and up and eventually slows down and stops going up and then starts to descend. And then if you have your lights on the appropriate parts of the Raven, they will actually flash. I'll figure this out and maybe demonstrate this next time, if just for fun. I do want to show you one more thing though, and that is, here is an example of some data that was taken by a Raven. And so if you have this particular software, you can see this data, whether you have a Raven or not. And the reason I think this is useful is because it shows you, and other altimeters are similar. So in this case right now, let's just say I want to see altitude based on barometer, or if I want to see the actual barometer value itself directly, that's kind of upside down version. So the pressure goes down and then eventually the pressure comes back up. Notice that if I look at altitude based on barometer, I have one parachute producing a specific descent speed, and then apparently I pull a second parachute right here, and then it comes down to the slower descent speed. And if I were to watch, let me just set that down for a second. Let me look at the axial G's as well, and I can see a definite spike right here. That spike means that's when an ejection charge went off. Also, of course, I see the burning of the rocket, so there's significant acceleration early on. And then notice here's another spike. So that means a second ejection charge went off, and both of them shocked the rocket enough that the accelerometer picked up on it. This is an example of multiple things being drawn on a single graph. These can be kind of confusing, but it's actually sort of interesting to look at these individually. There's one, there's the barometer, there's the temperature, if that's interesting to you. The Raven has more sensors on it. It has both barometers and also accelerometers. And so it can make decisions based on one or on both. I think that probably should do. And again, this is not the kind of altimeter that we're going to be using just because they weren't available. But I think it's useful to know what's out there. And hopefully next week we'll have in hand the AIM Extra. So we might actually spend a bit of time next week talking about the appropriate wiring for the AIM Extra and what kind of software goes along with that. which reminds me, next week we have to do two things. We have to talk about when to do our checkout interviews. And it's a little tricky to schedule a checkout interview without knowing when you're going to be finished with your rocket. You have to be finished with your rocket before you do your checkout interview. But I'm going to propose, and I've already posted this, homework 4 and vocabulary 4 next week. They're both up. And one of the homework things is talk to your team about of the following dates. And the dates, frankly, are any date after next week, because next week is our last lesson. If you are actually fully done with your rocket before approximately the beginning of December. And so, and the reason is I'm hoping if the weather cooperates and if people are interested in doing so, that we might be able to sneak out in early December and fly these rockets. You don't have to. I do want you all to fly your rockets. And so if you choose not to fly in early December, then we'll have opportunities in the spring. On the other hand, if you're thinking about getting involved in the competition, which requires building more rockets and test flying at least some of them, including this one, absolutely you should fly in December and get that out of the way. So those of you thinking about joining the competition, I think that's several groups here. I would suggest you work hard to have this rocket ready and flown yet this semester, and then you can spend all of next semester building the rest of the rockets that the competition asks for, including flying them with other altimeters like Ravens or Stratologgers, which you might be able to acquire by then if you don't already have them in hand. Okay, so we've sort of used up all of our time, but I would be happy to and curious about any questions people might have. Can you give us a blow-by-blow on the nose cone modifications? It turns out that there is a blow-by-blow in the slides, yes? Although it might not be as early in the slides as you might expect. Didn't you place those slides a bit later down?
Let's see, it's at 20.
Okay, Kelly, I'd recommend you look at the entire slide deck, not just stopping when the slides seem to peter out, because there might be some slides waiting for content, but the nose cone modifications are described in the slide deck. If you have questions after seeing that, this requires cutting something, not cutting yourself, making sure you don't damage the nose cone too much because you still want it to be able to seal and seat on the rocket, and making a big enough opening that you can get a pliers inside so that you can reach the nut that's going to go on the end of the eye bolt and then screw the eye bolt tight with a lock nut. Any other questions right now? I have one. We didn't provide a sled. What should a sled be made of? Is cardboard okay? Plastic? Metal? What should a sled be made out of?
I am just going to use scrap wood.
Okay, so Sophia plans to make it out of wood, and she said scrap wood, as in she's not even going to work too hard. She's just going to find some pieces of wood around here. Are you planning to laser cut it or not necessarily?
I will most likely laser cut it. Yeah, just to make sure the edges are nice and clean, but I think whatever way you can to get it to fit within the avionics bay is suitable.
Sure, most of the sleds that we have here are approximately an 1/8 inch thick, and this one happens to be made of plywood or something, and this one happens to be made of MDF. In other words, it's something that's a pressed product. And then you should also think about how you're going to hold those threaded rods. So one possibility is this one. This is kind of cool because this thing was laser cut and then it was, what is that called? Dovetail joints or whatever. You could all obviously glue those on. If you wanted to make it this way with tubes, that's fine. I didn't provide you with any tubes though, so you might have to go looking for tubes. One way or another, the sled has to hold on to the threaded rods because that's what provides the structure inside of your av bay. Get going on building yourself a sled. And then what I will do is I will send you a 9-volt battery harness, and I will send you an altimeter, and I've already sent you some wire, and you might want to find more wire if you really want to color code things. And then you already have the screw switch because that came with the kit. And if it didn't come with long enough wires in the kit, well, extend the wires. That would be a place for some soldering. Anybody else? Questions? Question is, what about that JB weld? So it turns out that the JB weld is useful in parts of the rocket that are going to get hot. And the place that we would classically use it, although it is not necessary for this particular kit, is if you are using a motor retention scheme that is glued to the motor mount tube, okay, and is made of metal in particular. So this particular motor retention scheme uses screws that are away from the motor mount tube and just have like washers. So it's actually true. We're not really counting on JB Weld for this kit. If you're going to go into the competition, you will probably want to use JB Weld because you'll want to show off the fact that you know how to use other kinds of motor retention, some of which really do require it. So I actually bought that before I purchased the kits, and I didn't realize this kit didn't need it. Anything else? Go ahead, Kelly. You can type in or you can talk to us. What about the grain stuff the directions stated we should mix with the epoxy? Okay, fair enough. You're allowed to build rockets with different kinds of epoxies. And some epoxies, West Systems epoxies come to mind. When you first mix them, they're very runny. And so you either have to let them set up partially and catch them at just the right moment and then use them quick, or you can mix powder into the epoxy, which doesn't do anything chemically. It just makes it stiffer until it's sort of like peanut butter. And then you can use it and it will still take, you know, the same number of minutes to harden. We're using the epoxy that actually is pretty stiff when you first mix it up. Not perfectly so, but so we're not even bothering with mixing powder into this epoxy. So the recommendation about mixing things into the epoxy, that's necessary for certain epoxies and not necessary for certain epoxies, including rocket epoxy that we're using. My favorite epoxy actually is called NoSeg, 3M, I forget the number, NoSeg. It's infinitely expensive though. And so rocket epoxy is a better way. And all of these epoxies are sort of comparably strong, but they have ease or less ease of use. So we're using one that's not too expensive and pretty easy to use. So it's a good choice. But again, if you're in the competition, you might say, oh yeah, I'm going to build it with other epoxies, in which case I might get some experience mixing powders into the epoxy. Not necessary for this kit build. Similarly, this kit build is not necessary to like wrap your rocket in fiberglass, but that's another skill that you might want to demonstrate if you're building a bunch of rockets and demonstrating skills. That's related to how strong the rocket body is compared to the motor you have in mind to fly it on. Famous last words. I might regret not wrapping these things in fiberglass, but we're not planning to. Anything else? Okay, well, thanks everybody for your attention. Again, next week, we're hoping, I mean, this really would be nice. I'm not expecting it to be true, but this would be nice, is that every rocket is done when we meet next week. Done except for the final touches. And the final touches we'll talk about, like drilling holes for bleed holes and vent holes and holes for screws and holes for rivets, lots of holes actually. We'll talk through where to put them, why we need them, and how to calculate how big they should be. That will be next week. And pretty much once you're done building and painting, if you choose to paint, I hope you do, and have all the proper holes in place, then your rocket should really be basically ready to fly. Okay, have a good night, and we'll talk to you next week.
Bye.
Oh, one more question here. Should we hold off on paint if we're going to do the competition for thematic needs? Well, yes, that's an interesting point. It turns out that in the competition, you're supposed to have multiple rockets, and they're supposed to be thematically related to each other. So if you want to wait to paint this one until you have decided exactly what you're building and come up with a really cool paint scheme later on, that's not a bad idea. Some people say you're always supposed to fly your rocket before you paint it, just so it earns its paint job. Since I usually build rockets for classes and we only fly them once, it's a little pointless not to paint the rockets before you fly them. But some people actually, superstitiously, I believe in that. So yes, I would be fine with you choosing not to paint the rocket, especially if you plan to paint it later and do so with some cool theme in mind, which you haven't decided on yet. That's okay. Don't take me too seriously, though. I do want these rockets painted, especially if this is going to be your rocket and you're not going to do other rockets. That's okay, but then do a nice paint job. We might have a coolest paint job prize.
Yeah.
We'll see.
Painted clear.
Painted clear. You know, I once built a transparent rocket. I didn't paint it clear, I made it clear. And that was interesting because then you could see all the innards. It was hard to find an appropriate material to do that with, but anyway, it was an interesting educational rocket because you could see the insides. Later on, we built a split rocket where you could see the insides and we didn't bother with the transparent one. Hard to find, yes. One time, here's what you should not do. You should not paint your rocket sky blue. One group painted a really nice sky blue rocket and it went up in the sky and it was never heard from again. We never found it, in part because we couldn't see it because it matched the sky. That was bad. I would suggest you paint your rocket something that is visible. Okay, have a good night, everyone.
Thank you.
Thank you.
Thank you.